Okay, we are going to go over some examples on how to solve um, inequalities, linear inequalities with two variables. So the first video talks about the process, and in this video I'm just going to go over several different types of examples, similar to the ones you'll find in your homework. Okay, so we have this first example here. 6x plus 3y is less than 18. So be thinking, okay, we're going to use a dotted line because it's just less than. So a dotted line when we graph our boundary line, dotted line. So we're going to graph the line 6x plus 3y is equal to 18. We're going to make it dotted, and then we're going to decide which half plane we're going to shade. So the easiest way to do it when this is in standard form like it is, it's not in slope-intercept form, the easiest way to graph this is to find our x and y-intercepts. To do that, you're going to let the opposite variable equal 0. So what we're doing is find x and y-intercepts, because once you find those, you've got 2 points and you can graph the line. So to find the y-intercept, we're going to let x equal 0 and solve for y. So if x is 0, we'd have 6 times 0, which is just going to be 0. You don't even need to write that, but you can. And we're graphing the boundary line, so I'm going to say equal. So I'm going to ignore the inequality for a minute. And so 6 times 0 is 0, so I'm trying to find where does 3y equal 18. And if I divide by 3, I get when y is equal to 6. So when x is 0, y is 6. So 0, 6 is 1 point on my graph. And then to find another point, if I let y equal 0 and then solve for x, I'll find my x-intercept. So right here, this is my y-intercept, and this is going to help me find my x-intercept. So I'm putting in 0 for y this time, and let me get rid of this. So if y is 0, I'm putting 0 for this guy, I'm going to have 6x plus 3 times 0, which is going to be 0, so I don't really even need to write it, but I'm going to. You don't have to. 6x plus 0 equals 6x, so 6x equals 18. Divide by 6, and 18 divided by 6 is 3. So when x is 3, y is 0. So our x-intercept is right here. I have my y-intercept, I have my x-intercept. I can draw that line in. Oops, needs to be dotted. So here we go. I'll use this guy. There's the line that passes through those points. And it's a line, so it should have arrows on either end. And when you use your program for XYZ, it should automatically come up with these arrows. But you're going to have to choose dotted. And then if you just run a line through those 2 points, that should be good. But now we have to shade half of a plane, and the way that we're going to figure out which half we're going to shade on the underneath the line or above the line, to the left of the line or to the right of the line is another way to think of it. We're going to pick a test point not on the line. You can pick any point that isn't on the line, but generally speaking, if 0, 0 is not on the line, that's going to be our easiest point to test. Here's 0, 0, it is not on the line. I'm going to put it in the inequality. If it makes the inequality true, I'm going to shade that half. If it makes it false, I'm going to shade the opposite half. So putting in 0 for x and 0 for y, this entire side is going to end up being 0, because 6 times 0 plus 3 times 0 is 0. Is 0 less than 18? And yes, it is. So this is a solution. Any point that you pick over on this side should be a solution, and we can check it. I'll just check the other side. So like we could put in the point 1, 1. It should make it true. So 6 times 1 is 6. 3 times 1 is 3. 6 plus 3 is 9. 9 is less than 18. You will get any point on that side of the line will make it true. Any point on the other side should make it false. So if we pick a point like, let's say 6, 0 right here, if I put 6, 0 in, if I use this test point, it should make it false because it's anything on the other side should make it false. So 6 times putting in 6 for my x, and I'm going to put in 0 for y. Is that less than 18? Well, 6 times 6 is 36, plus 3 times 0 is 0. 36 is not less than 18. It makes it false. So that's a way to double check to make sure that you shaded the correct side. All right, next example, 6x minus 4y is less than or equal to 24. So this is going to be a solid line. So solid line because it is less than or equal to. Again, this one is in standard form, so we can do the x, y-intercepts, and we're just going to let x equal 0, and then we're going to go back in and we're going to let y equal 0, and we're going to find the other variable. So if x is 0, plug it in, and we're graphing the boundary line, so we're going to say equals. So 6 times 0, that'll be 0, minus 4y equals 24. This is 0 minus 4y, which is just negative 4y. So I have to divide by a negative 4, and I get y equals negative 6. So when x is 0, y is negative 6 this time, so it's the other side of the origin from the last problem. And then we're going to do, we're going to let y equal 0. So I'm going to have 6x minus 4 times 0 equals 24. So that's just 6x equals 24, because 4 times 0 is 0. Divide by 6. Divide by 6, you get x equals 4. So 4, 0 is also on the graph, which is right here. I have a solid line that I'm going to throw through those 2 points. And I have to decide which half to shade, so think about what you're supposed to do there. We are going to pick a test point. Pick 0, 0. It's the easiest one. It's not on the line, so use it. So I'm going to put 0 in for x. I'm going to put 0 in for y. I'm going to see if this makes it true or false. Oops, don't change it to an equal sign. Is that less than or equal to 24? 0 minus 0 is 0. 0 is less than or equal to 24. This point is part of the solution. It's true. So since it's true, we're going to shade the half plane that contains the point 0, 0, which is right here. So we're going to shade this half up here above the line. Now, if you are wanting to, you could have, instead of finding our x, y-intercepts, we could have rewritten this in slope-intercept form, and I'm just going to do that just in case somebody's really like stuck on doing that. And it's not it's not that big of a deal, not that different. You need to just solve it for y. So you would subtract 6x, and on this side the 6x goes away, and I have negative 4y equals, and I'm going to put the negative 6x first because I want it to look like mx plus b, y equals mx plus b in slope-intercept form. When I solve for y, I have to do that by dividing everything by 4, negative 4, sorry. So I get y equals 6 divided by negative 6 divided by negative 4 is positive 3/2. And then 24 divided by negative 4 is minus 6. So if you look, if I graph this, the y-intercept is negative 6. The slope is up 3 and over 2. So I get that same line. So either way that you want to do it is fine. I think the x and y-intercepts, if you just practice that, that'll be the way that's going to be the easiest. Now this problem right here is already in slope-intercept form, so don't do that. This is my y-intercept, and this is my slope. And the slope is a whole number, so put it over 1 so that you can think of it as rise over 1. So I'm going to put a point at 2. That I know that point is on my graph because that's my y-intercept, and then I'm going to go up 3 and over 1, up 3 and over 1. If I go down 3, I have to go to the left one. That's a negative over a negative, which would make it positive. You don't have to graph all those points. All you need is, you just need 2 points, but, and it's a solid line. I forgot to talk about that, but because it's less than or equal to, it'll be a solid line. That bar right there makes it a solid line. We're going to test a point. 0, 0 again is not on the line, so we can still use 0, 0. Again, you can use any point you want, but I'm just telling you that 0, 0 is usually the easiest to just like work with. So if 0, is that less than or equal to 0 plus 3 times 0, which is 0 plus 2? Is 0 less than or equal to 2? Think about it for a second. It is. It makes it true. These get a little bit harder when if you're dealing with negative numbers, so you really kind of have to focus. So this makes it true. That means everything over here makes it true. And again, if you want to double check yourself, you can test a point on the other side of the line. It should make it false. Or test any other point that's on the same side that we shaded. It should make it true. All right, so why don't you go ahead and graph this one on your own and then check your answer when you're done. All right, so you have a y-intercept of -1, which is down here, and you have a slope of 2, so you're going to go up 2 and over 1, and that point is right here. Oops. And then it's a solid line through those points, and I tested 0, 0, and it made it true, so I shaded the side, the half plane that has 0, 0 in it, and there's your solution. Okay, I'm going to skip forward to another type of question here, where you have multiple parts, and the point of it being is to pay close attention to what you're supposed to do when. So you have a problem like this in your assignment, and it says to solve this inequality. So we're not graphing anything, we're just going to solve this inequality for y. Because this is a linear inequality in one variable. And so if you were to graph it, we would now graph it on a number line instead of on an XY coordinate grid. So solving this, we're going to get y by itself on one side. So we subtract 5. The 5's are gone. I have 6y is less than 25. Divide by 6, and you get y is less than 25 over 6. That is a perfectly fine number. If you wanted to put it in a mixed number, it would be 4 and 1/6. Part B also says to solve. So that's same process, except we're going to need to flip the direction of the sign because we're going to have to divide by a negative. But subtract 5, and you get -6y is less than 25. Divide by -6, divide by -6. I'm going to go over here. This is y. Flip the direction of the sign. It's going to go this way. And then, oops. Y is greater than -25 over 6. You can have the negative in the top, in the bottom, out front. It doesn't matter. That's all the same. Part C says solve for y. So now, if we're solving this for y, I have 5x plus 6y equals 30. I'm going to subtract 5x from both sides, and I get 6y equals -5x plus 30. You can also write 30 minus 5x, it doesn't matter. But if I wanted in slope-intercept form, I would want to put the x term first. Divide by 6, and you get y, it was an equal sign, so equals -5, 6x plus 30 divided by 6, which is 5. Okay, this next example, write it down and do it, and then check your work, and then I'll have to make one more video for the last type of problem. All right, so you have a y-intercept of 5 up here. You have a slope of -5, 6, so go down 5 and over 6. Get a second point. Dotted line, because its y is just less than. I picked a test point, again, of 0, 0. It made it true, because you end up with 0 is less than 5, which is true. And so you shade this half of the plane. Okay, the next type of problem that I'm going to do looks like this, and you'll see it's one of the last types of problems you have to do in your homework. So it'll be pretty quick video, so catch that in the next one. All right.